Welcome to Talkin Science, where we dive into the stories making headlines in the world of science and space. I'm Matt Miller. Dr. Brad Tucker is here. Brad, happy Tuesday.
How's it going?
Really good, my friend. Really good. Let's get the headlines in the 26th week of 2021. A long-period comet hundreds of kilometres in diameter is heading to the inner solar system. Not one, but two discoveries of the most extreme reaction in the universe, black holes gobbling up neutron stars. And doing the space laundry, NASA and Procter and Gamble are teaming up to stop dirty clothes being incinerated instead of washed. Brad, it's NAIDOC Week here in Australia, a celebration of the traditional owners of the land upon which we work and live. For me, this is Yuggera country. What we call Canberra is Ngunnawal country. In the spirit of reconciliation, Trekzone acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. It is just incredible to think, Brad, that for tens of thousands of years before the first fleet arrived in Botany Bay, there were people living and working this land and admiring and studying the skies.
And there's still a lot we're learning from them in terms of their discoveries, and it's becoming, I think, a bigger area, understanding that long baseline that we get with their science and knowledge and informing even discoveries to today. So it's an important recognition of the science. It doesn't just happen this week. Well,
before we get into the show, a quick reminder of the socials. We can find you on Twitter at btucker22. I'm on Twitter at Miramat86 and, of course, Trekzone exclusively on Twitter. Plus, find our YouTube channel for the latest eps and on your podcast app of choice. And you can get behind-the-scenes goss and early access to all Trekzone podcasts by becoming a member today. Click the join button on any Trekzone video, go to the Trekzone/support, or put your phone up to the QR code on screen throughout the show. Brad, it is Talkin Science Fest here at Trekzone. All week I've got great guests lined up to celebrate Australian science and space work. I'm going to give you a quick sample now of each chat. First up, David Towney beamed in. He's a Wiradjuri man, and we spoke about the traditional name bestowed on the park's radio telescope as part of NAIDOC Week last year. I asked him what it meant to the Wiradjuri people.
Well, it means a lot as a local Wiradjuri man. My little community is the main Aboriginal community close by the park's telescope, or Mordiang. And the whole area is significant, I suppose, as the reasons why they originally built the telescope in the first place. I suppose the country is a special place. We've got sites close by Mordiang, and the open sky is part of the reason why we chose the name as well, and part of the reason that I suppose the telescope connects to the sky. So when you put all that together, and it's a significant international monument, I suppose, the park's telescope, Mordiang, giving it an Aboriginal name actually attaches it back to our people and attaches it back to the country where it's built.
Dr. Bobby Serini is the General Manager of Questacon. We dive into the awesome hands-on exhibits and learning that they allow kids and adults to experience. But where did it all begin?
Well, if you think about the history of science and the way that people have started to engage with it, really back in the 70s, there started to emerge a global movement for more hands-on science. And that followed hundreds of years of the tradition of scientists giving lectures and exploring demonstrations. You might remember there were some great electricity demonstrations done by people like Michael Faraday at the Royal Institution in London. So, over the years, science centres have developed as places of community-based learning, essentially, where anyone is welcome. You can go in, you can get your hands dirty with science, and you can explore some of the fundamental principles, whether it's physics or chemistry, whether it's biology, whether it's mathematics.
Operations Team Leader Richard Stevenson at Tidbinbilla, the Deep Space Communication Complex, talks about their work, and I asked him about how missions control get in touch with their craft or rover.
Some missions might need that real-time feedback. We have the Chandra telescope, which is obviously a real-time support. They'll send commands. They need to see those acknowledged in their telemetry to send other commands. So that's a real-time support. But we also have supports like Geotel, for instance, where It's a regular support that comes up, and we'll track it, we'll record the data, and then when project comes in the following morning, they can grab it on their PC.
John Sarkissian is the operations scientist at the Parkes Radio Telescope. We'll be heading back there to learn about the dish's operations.
And when it was built, it was the second largest but most advanced radio telescope in the world. And from its very inception, within just the first year alone, it made discoveries that really established its reputation. It discovered the magnetic field of the Milky Way galaxy, for example. It also identified the very first quasar, the most distantly known objects in the universe. And then in December of '62, just over a year later, it tracked the very first interplanetary spacecraft, Mariner 2, when it flew by Venus.
And the last part of Talkin' Science Fest this week is my chat with Southern Launch's CEO, Lloyd Damp. We dive into their recent approval to develop the Whalers Way site for 3 test launches. And in this clip, I asked him what the difference is between there and the Caniba test range, which they have launched from in the past.
With Caniba, it's about suborbital launches. So the rockets go up, out into space. They deploy a telescope or a camera or test a bit of equipment before then falling back to Earth under a parachute. And the key thing being Caniba is out across the deserts. You can go out there and actually collect your telescope after the event and inspect it or download the information from it. Whalers Way is all about getting the rocket up into space and then accelerating it to 11.2 kilometers per second so that it stays in orbit around the Earth. So that's the fundamental big difference between the 2 launch sites.
All right, Brad, time to get into our usual swing of things. First up in our headlines, we knew this was going to happen after Jeff Bezos announced he'd beat Elon Musk into orbit. Richard Branson is upping the billionaire stakes, and he's decided that he's going up on Virgin Galactic's first passenger flight in just a few days.
Yeah, look, once they got its FAA license, as we highlighted last week, I'm not surprised they quickly scheduled this, right? Just to slide in and beat it. And I think we said we wouldn't be surprised if they try to slip in a flight beforehand. And here we are, aiming for next Sunday US, Monday here in Australia. Now, obviously, weather delays and things like that can go wrong. But as of now, that's their plan. And we'll see how it goes. And it's going to be an interesting week to see how it all unfolds, especially also, I guess, how Blue Origin responds after Virgin Galactic planning on as its successful flight.
Absolutely. And while thousands have signed a petition to not let Jeff Bezos back to Earth, he's not only taking along his brother and an auction winner, but also Wally Funk, one of the so-called Mercury 13 group of female astronauts.
Yeah, so look, she, as you said, when the Mercury program was going on, NASA was not allowing females to be in the astronaut program. Wally Funk led a group of females to show, well, women can go into space. There's something physiologically different there, and trained and prepared to do it. Now, obviously didn't go into space on one of those flights, but always was seen as quite a prominent, groundbreaking member of the group to get females into space. And in fact, if you saw in that just photo, she had a Virgin Galactic outfit because obviously she was keen on going up there. But when Blue Origin scheduled it, Blue Origin scheduled her. So they're, even Virgin Galactic and Blue Origin are fighting over who to take into space, let alone when to go into space.
Incredible stuff indeed. Well, Brad, set your alarm for 2031. Astronomers are predicting that C2014 UN 271, as you can see here, it's a mega comet and it's going to swing past the inner solar system.
Yeah, this is when you say mega, you're right. This is a giant comet, the likes of which we really have never seen before. Most comets are a couple of kilometers in the nucleus, so that's the main body of the comet. Obviously, as it goes around the sun, bits of it melt and leaves its beautiful tail and debris behind. The body of this comet has been measured to be a couple of hundred kilometers, literally hundreds of times bigger than the average comet. And when it gets into the solar system, it's never going to quite reach Earth or Mars, but when it starts to get into closer bits of the solar system, it's going to be a big, amazing sight to see. hopefully in the skies.
Well, the astronomers who made the discovery only recently found it amongst a stack of photos from 2014 taken by the Dark Energy Survey, proving that you might be looking for one thing out there and find something completely different.
Yeah, so, because the Dark Energy Survey, which is part of what I've been on, and we've talked about it before, because you're taking all of these images pretty much every other day, usually every third day, to look for supernova and things like that, you notice things that change. And this includes what we call minor bodies, minor planetary bodies, so comets, asteroids, potentially dwarf planets as well. And when it was seen, it was quite a surprise that this thing was so far out, because the things that are really far out move really slowly, apparently, on the sky. It takes a long time to see these things moving across the sky. And not only was it discovered and measured that it was, hey, this is really far out, but when they started to follow up observations modeling of it, realized, hey, this thing is pretty gigantic.
Well, if you thought a year here on Earth was long, try living on this rock. It's taking a few million years just to make one pass, as you're saying there, Brad. Quite a long time to do just one thing.
Yeah, and these really come from what we think is the outer body of the solar system, really to the edge. We think comets come from something called the Oort cloud, and this could potentially be on the it is potentially on the outside of, say, Pluto and all the other dwarf planets and things like that. It's really far away. And we have the comets that are what we call periodic, like Halley's Comet, that kind of are doing these loops around the sun. But occasionally comets from outside there get bumped, head into the inner solar system, and do this very long orbit, as we're seeing, as you're saying, here. It's a remarkable find to see something like this. And it really just goes to show not what lurks beyond, but what lurks beyond. How many things are out there that have yet been discovered?
Exactly right. Well, its brightness is increasing, hence the theory that this is a comet. So efforts are mounting to study it and prove that it's forming a coma. Obviously, an active comet is melting from the sun, and that's where the increase in brightness is coming from. And if that's happening, then there's a coma, and we have a comet on the way.
That's right, because it very well could have been a dwarf planet out there. It could have been a really far dwarf planet, but we would not expect it to change in its brightness very much. Same with any other thing like an asteroid or something like that. So the fact that it is changing does suggest that as it's getting closer into the solar system, as the sun heats up the nucleus, you start to melt, and therefore you start to brighten the object, like we see when asteroids go around. So that's kind of led to this conclusion that it's a comet. But as you said, people want to obviously observe this. And, we have a little bit of time to prepare, given we have till 2031 on its close approach. So there's at least some preparation time that people can make and plan before this thing comes.
Well, Hale-Bopp, which wowed astronomers and stargazers in 1997, was only 60 kilometres across. What can we expect to see in a decade's time, Brad, all things being equal and not collision-y?
Yeah, look, that's right. You want to make sure it doesn't collide with the planet. As of now, it appears the orbit probably won't happen, but you do want to better refine its orbit, as always. And, given this is going to be, multiple times brighter than, he said, Hale-Bopp or some of the other comets that we get, it is going to be a very bright object when it comes in the sky. I guess the trick always with comets is how close it gets around the sun, how the brightness happens relative to it being visible on Earth. Obviously, these things can come around the sun, and therefore then they're almost visible during the daytime, but if they're obviously not bright enough during the daytime, we don't see it. So you kind of want the right balance of being able for it to brighten by getting closer to the sun, but also be visible from the Earth after that. So it's a little bit of a waiting game to see exactly how it all plays out.
Well, a billion years later, Brad, we've witnessed not one but two extreme reactions with two separate black holes gobbling up two separate neutron stars.
Yeah, we've talked about, black holes gobbling up other black holes. We've talked about neutron stars colliding, and this is kind of the third of the pair that people have been waiting for, and that is a black hole and a neutron star. So a neutron star is a an old star. So when you get a massive star that explodes, on the inside, you condense all of the remnant matter down and you create a neutron star. So it's essentially a star made of neutrons. It's a very dense, relatively small, sometimes only 50 or so kilometers, sometimes 20 kilometers wide. And there's not much to it. That's kind of it. But we do think, and we always thought, that they could be around not only other neutron stars, as we've seen, but other black holes as well. And as you said, this was the first time we saw the collision between two of these objects, kind of confirming that, yes, you can get this combination of objects, and we can also see it at least through gravitational waves.
Well, this is the latest in a string of discoveries for LIGO and Virgo. In 2015, they detected the merging of two black holes. 2 years later, the collision of neutron stars. And in 2019, they got a whiff of another black hole swallowing a neutron star, but that one was never confirmed.
Yeah, that one was just on the edge of the detection level. So it was hard to pinpoint, was it noise? Was it something else? And so even though the data looked like it was real, and if it was real, it looked like it was a black hole neutron star merger, it was not conclusive. But in the latest observing run, which has the ability of not just LIGO doing it, but there's also Virgo in Europe. There's also now CAGRA, another gravitational wave detector that has come online. That means there's more sensitivity, more points of pinpointing and essentially triangulating where it is, and the ability to figure out what it is.
It seems like this may be a regular occurrence on a universal timescale, of course. What do these discoveries show us, Brad? And could they lead to a change in understanding of physics? Sorry.
Yeah, look, this is a good point. We're just now starting to find these things. And, 50 stars explode every second. That means there's probably dozens of neutron stars being created. But they're really hard to see. You don't get to directly see neutron stars. You don't really get to directly see these small black holes. We obviously can detect the supermassive black holes are hard to find. So it's really starting to tell us a lot about the populations of these objects, how many exist, in what fractions and what ratios, and also, I guess, how long and how big they can get. You're kind of trying to get the parameter size. It's really putting together the full picture of a star's life. We can see a star being born. We can see these stars when they're born in their clouds. We can see all the different stars as they evolve and grow and become bigger stars. We can see stars when they die. It's now starting to see how these stars end their lives as well, and that's the last key part that these gravitational waves are starting to uncover.
Well, lastly this week, Brad, something I never even considered, but now that I've learned it's a problem, I'm left wondering why I never thought of it in the first place. Dirty space laundry. It's a thing, and it's a bit of a big deal, Brad.
Yeah, look, I love this story because it's exactly what you're right. No one ever thinks about that. But it is a very practical aspect of living in space. It's a practical aspect of living. You have to change your clothes. You don't want to get smelly. But the problem is you do get smelly in space because you can't easily wash your clothes. And right now, as you said, there's a company in the US, Tide, which is owned by Procter and Gamble, is working with NASA to find a way to have astronauts be able to wash their clothes in the limitations of a microgravity environment, i.e. you can't just have a washing machine or a basin to scrub your clothes.
And I'm assuming that the astronauts are going to be smart enough to not eat those Tide Pods, but immediately we can think of the crew on the space station. They're not just the T-shirts, but pants, underwear, socks, etc. Everything that you wear, it's all getting chucked in the rubbish once the astronauts can no longer take the smell of it. It's pretty icky stuff when you think about it, Brad.
It really is. We talked about the weight limits and limitations of getting things into space, right? So you can't have multiple change of clothes. You have to exercise a lot. You have to work and you have to sleep. And so you have to deal with this very practical aspect of living in space. And yeah, the way to solve the weight limit was you just wear it until you're so smelly you can't deal with it anymore. And then you put it in these containers that go into the capsules, and as the capsules re-enter the Earth's atmosphere and burn up, their dirty laundry burns up with it. I mean, the fact that there's literally has been dirty underpants burning up in the Earth's atmosphere is not something people normally think about.
No, absolutely not. Well, of course, the crew, as you alluded to there, they have to exercise, especially on these long duration missions, for about 2 hours a day to compensate for the muscle and bone degrading effects of weightlessness. With former astronaut Leland Melvin speaking that they run through a set of T-shirts, shorts and socks per week. It is incredibly wasteful.
Yeah, that's the other thing. It is just not practical. It is wasteful. And it's just practically smelly. There is not a win for anyone here. But there hasn't been a better way. This has just been the way you had to do it. This was not what they're thinking. It's a lot of these things in space, we don't necessarily think of the practical aspects the astronauts have to go through, yet they do. And I think, it's really important when we start to think about it. We start talking about private people going to space and space travel. It is no different what they are going to experience than what these professional astronauts have, which means, yes, they are going to run into these issues as well, from how do you go to the toilet in space, how do you brush your teeth and wash your clothes. So as we start embarking on more people going into space in lots of different ways, it becomes more of a necessity to solve this problem.
Well, antimicrobial clothing is one option, but it's not viable long-term, apparently. The dirty clothes simply become toxic, and that's an actual toxic object. Something needs to be done with them. And as you say, Procter and Gamble, the maker of Tide in the US, working on a truly water-saving washer-dryer combo for the moon and beyond. And as part of that answer to people that say, why should we bother going into space? Here's a very good reason, because if they can come up with this washer-dryer combo that uses very limited water, it could be shipped to arid areas of the planet too.
Yeah, that's exactly right. This is always this great example of space where when you start to think about the solutions that are needed to solve the problems in space, they sometimes propagate through to other very practical ways and problems that we have here on Earth in a very sensible way. As you said, if you can start dealing with laundry problems with water efficient ways, let's say, that's a win all around. And so this is kind of a cool thing that it may lead to.
Absolutely. Well, we're in the middle of Talkin' Science Fest, as we talked about earlier in the show. It's happening all week this week, Brad. 6 podcasts across 6 days. I wish we were on the road, but nonetheless, we're featuring the Aussie science and space stories via video calls. Be on the lookout for them. But for now, that's how we talk science, Brad. It's great to pick apart the stories of the week with you. Let's do it again next week.
Thanks.
Keep up to date with Twitter. Catch new podcasts daily on YouTube. Plus, we're beaming to your favourite podcast app 5 days a week. Just search for Trekzone and subscribe.